I'm glad you are watching this lesson. I'm teacher Katimbo Richard, teaching mathematics primary 6. Today we are still looking at data handling, or graphs and interpretation of information. We looked at the different graphs, like a line graph, like a bar graph, a histogram, pie chart called a circle graph. Today we are looking at a line graph, then later we shall handle the data that is in statistics and see how we can deal with such. And now we are starting with a line graph, and when you watch this lesson successfully, you will be able to answer all the activities from page 64 all the way to 71 of our book term 2, P6. And then we are starting with example number 1 about the line graph. And we start. It reads, the graph below shows the number of liters a car consumed throughout a section of the journey. The graph below shows the number of liters a car consumes throughout a section of a journey. Study it carefully and answer the questions that follow. Always study before you answer any question, for if you don't study, you will fail. Don't answer as you study, answer after studying, or if further study is taken. Now, like the word line suggests you follow a line to read a line graph. You follow a line to read a line graph. So you follow a particular line. So I've got this vertical axis and this horizontal axis. Now here the vertical shows the distance in kilometers, so that is covered. When one refuels, when one puts in the fuel in their car. So we are going to look out for the fuel consumption rate. So it's like knowing that a liter does this journey. Look at 1 liter of fuel. So 1 liter of fuel, you follow a line after the graph. This is the graph, after the graph. So 1 liter does 10 kilometers. Look, 1 liter does 10 kilometers. That's why 2 liters do 20 kilometers. Then 3 liters do 30 kilometers. 4 liters do a journey of 40 kilometers. And 5 liters, of course, we do 50 kilometers. So that's how we study. So the fuel consumption rate is 1 liter does a journey of 10 kilometers. Every 10 kilometer drive, a liter goes. That is how this car consumes. So that's the rate of consumption of fuel. So that fuel consumption rate will be able, or will help us answer all the questions that 1 liter goes for every 10 kilometer drive. So then you will be able to answer. That is for that particular car, for that particular owner. So read then the questions and answer. Calculate the distance covered with 1 liter. So we have already learned a liter does 10 kilometers. However, being that the examiner told us to calculate, we look out for the whole journey. The whole journey is of 50 kilometers and is done by 5 liters. So you get 50 kilometers divided by 5 and then divide accordingly. 50 divided by 5, you get our 10. So that we say 1 liter does 10 kilometers. So because we have been instructed to calculate, show that you are calculating, much as you know that 1 liter does 10 kilometers after that thorough study. So 1 liter then does 10 kilometers when you get a whole journey up to where the graph ends. This is what's called a graph, so called a line graph. So 50 kilometers are done by 5 liters, or 5 liters do a journey of 50 kilometers. So say 50 kilometers divided by 5, so you get what a liter does. A liter does a 10 kilometer journey. Then that fuel consumption rate will be used in Roman numeral 2. The question is, calculate the distance covered with 3.5 liters of fuel. So you say, since 1 liter does 10 kilometers, then 3.5 liters will do 3.5 times 10 kilometers. So then convert this mixed fraction to unequal fraction. Numerator, sorry, denominator, that is the whole number plus numerator out of denominator. That is 3 times 2 times 3 plus 1 out of 2. 2 times 3, you get a 6. A 6 plus 1 gets 7 out of 2 now. So 3.5 liters, we do 7 out of 2 times 10 kilometers. We say by 2 once, by 2, 5. Multiply 7 by 5. And you know that 3.5 liters will do a journey of 35 kilometers. You already know or see that here every square shows 5 kilometers. So when you count even here, you will see that this is 5, 10, 15, 20, 25, 30, 35. You go up where you will see it will be 3.5. So 3.5 liters do a journey of 35 kilometers. So show the working, because you have been told to calculate. You must show the calculations, but you must be in line with the graph, if at all it was drawn to scale. So then we go to part B. Find the capacity of fuel liters needed to cover 16 kilometers. So whichever question that comes, use the journey done by a liter. So they are in need of fuel. So whatever is asked must be brought on the right hand side. Since the 1 liters and short liters are the ones written on the right hand side, you say 10 kilometers are done by a liter. What about 16 kilometers? You get 16 divided by 10, you get a liters, where 16 out of 10 makes 1.6. So you need to have 1.6 liters to do a journey of 16 kilometers. That's what is done. All in all, you must have that rate of consumption of fuel where a liter does 10 kilometers for this particular number. Please, to answer anything. Then part or Roman numeral 2 or part B says find the capacity of fuel liters needed to cover 40 kilometers. Do the same. 10 kilometers are done by a liter. What about 40 kilometers? They will be done by 40 divided by 10 answer the liters, and then divide by 10 by 10. You will need 4 liters of fuel to go as far as a 40 kilometer journey. That's the way we work out and interpret information on a line graph as we continue. So that's how we interpret the information or the data given by the line graph. Now we are going to look at the statistical data. Now the table below shows liters of milk which John collected from his farm in a week. The table below shows liters of milk which John collected from his farm in a week. We've got days and liters. Days and liters. On Monday, this John collected 12 liters of milk. On Tuesday, 16 liters of milk. On Wednesday, 12 liters of milk. Then on Thursday, 16 liters of milk. Friday, 13 liters of milk were collected by John. Then on Saturday, he collected 12 liters. Then on Sunday, he collected 10 liters. Having studied what they have brought for us as data, then we shall answer the questions. Find the mode. Find the mode. Or find the model collection of liters by John. So for the liters of milk. Now mode. must be understood. What's the meaning of mode? Mode means the most appearing number in the given data. What is mode? Mode is the most appearing number in the given data. So it requires us to draw the table of frequency, called the frequency table. So since they are saying the most appearing number in the given data is called mode, you write here mode and frequency. Mode and frequency. How frequent is the particular number? Say number frequency. Don't say mode. Say number frequency. Because we are ascertaining the most appearing number. So the first number here is 12. Then how frequent is it? Count the number of times 12 appears. So 1, 2, 3 times. That's the frequency. 12 appears thrice. Then go 16. How many 16s do you have? 1, 2. So 16 appears twice. Then 13. You have any other 13? No. It appears once. Then 10. Do you have another 10? Of course, no. So we don't have any other 10. So 10 appears once. So we said mode is the most appearing number in the given data. Look at the numbers you have. Which number appears most? Good, 12. So our mode is 12 liters. Is 12 liters. So put here liters of milk. So 12 liters. You can as well stop at 12 or put 12 liters. So 12 liters were corrected more severely than other liters. So that's how we find the mode. The other day they will ask you for the model frequency. You do the same number frequency, show the whole table. This time they will be in need of the 3. You say model frequency is equal to 3. If they ask for model frequency, you do like you're finding the mode, but you want the frequency here. So instead of the 12, use 3 this time. You say model frequency is equal to 3, whereas the mode is 12 liters. Ensure you answer accordingly. Then find the median of the given data. Now, median means the middle number. The middle number after organizing or arranging the given data in either ascending or descending order. Please, that is what's called a median. So, please write them in ascending order, meaning in increasing order, starting with the list. So we say 10, 12, 12, 12, 13, then go 16, 16. You write all the numbers but in ascending order or descending order. So here, this is ascending order, meaning starting with the least number to the greatest number. Whereas the opposite is descending. You start from 16 then if you want it. You would say 16, 16, 13, 12, 12, 12 again, then 10. So that's what you do. That is for descending order. So but now here we have ascended. Now let the data be paired so that you remain with the one in the middle, and that will be the median. So 10 is paired with 16. Then this is 16 is going to be paired with another 12. Here and here we go 13 and 12. So the middle number is that one. That is the 12. Called the median. So therefore my median equals 12 liters. Or just 12. So you can put liters or not. So then we go. Find the range. Range is the difference between the highest number and the least number in the given data. So therefore you say range equals highest minus lowest. The highest number is and was 16 liters. Then the least or lowest was 10. So you get 16 minus 10. So the range in the collection was 6 liters of milk. Was 66 liters of milk. That's the way we answer that one. And in case you ask for the range, you say range equals highest minus lowest. Then they will ask you for the mean. They will ask you for the mean. You say mean is the same as average. Mean is got by this formula. Mean is equal to sum of data out of number of data, or sum of items out of number of items. How do you reach the sum? By addition of the given data. So we add all of them and divide by their number. So we say mean, in the next step we say mean equals 12 plus 16 plus 12 plus 16 plus 13 plus 12 plus 10 out of their number 1, 2, 3, 4, 5, 6, 7. So you add them and divide by how many they are. So that's what we have written here. And now, for easy addition, I paired them. So that's what's called associative property. So do associate them. Where 12 plus 16 you get 28. 12 plus 16 again you get 28. 13 plus 12 you get 25. And then a 10 out of the 7. Pair again for easy addition. So 28 plus 28 you get 56. 25 plus 10 you get 35. Then out of that 7, then add these finally 56 and 35. Align them vertically, that is in their corresponding place values of 1s and 10s. That's 6 plus 5 you get and 11. Write 1, root 1. Okay, root 1. Say 1 plus 5, you get a 6. 6 plus you get 9. So the sum of the data or sum of items is 91. So 91 to be divided by 7. Start our calculations by 7. 7 by 7 once. 9 by 7 1 remainder 2. It goes to the 1 and makes it 21. So you continue and say 21 divided by 7 you get a 3. So our mean is 13 or 13 liters. If you want to put the 1 liters, so the mean collection, if that is if every day the collection was the same, this man, John, would collect 13 liters daily. So that is the mean collection. So mean assumes equal share. So assuming each of the days listed here had the same collection of liters, how many liters would they be? Each day would be having 13 liters. But now there is deviation or variation in collection because mean was not used. So every day would be having 13, 13, 13, 13, 13, 13, 13. So mean assumes equal share, although the data may be defined of that equal share. So that is how find the mean given that. Now application of that average or mean as well as the range. So let's look at example number 3. Example number 3 says the range of two numbers is 9. The range of two numbers is 9. If the largest number or the greatest number is 16, find the lowest number. Remember I said range is the difference between the highest and the lowest number in the given data. Now you apply highest minus lowest equals range. Highest minus lowest equals range. Well, the largest number or highest number 16 is the lowest that is being asked for. You say 16 minus the lowest equals the range, which is 9. So substitute accordingly, we want to get this L, which is in the place of the lowest. Now start solving algebra. 16 being a positive integer is only crossing the other side when it's a negative. So we are going to subtract 16 for both sides to make it go the other side. So go 16 minus 16 minus the lowest equals 9 minus 16. So that you have got 16 minus 16, which is a 0. It's no longer this side. So this side will remain with negative L. So negative L equals 9 minus 16. Now that 9 is less than 16, we first know 16 minus 9. What's 16 minus 9? 16 minus 9 is actually a 7. It's actually a 7. 16 minus 9 is a 7. So 9 minus 16 is a negative 7. So if negative L is equal to negative 7, we need a negative this side by division of other side by negative. So we divide other side by negative, thereby writing negative L divided by negative 1 equals negative 7 divided by negative 1. So that a negative and negative are positive either side. So positive L is equal to positive 7. So the lowest number is a 7. The lowest number is a 7. So that when you sum up 16 and 7, you get a 9. So it's the difference between the lowest and between the highest and the lowest. 16 minus 7, you will get a 9. So the lowest number is actually a 7 when it's done through the rightful procedure. So using highest minus lowest is equal to range, then use algebra to help you answer accordingly. As we go to number 4. Example number 4 is about application of average. The average age of 5 pupils is 11 years. The average age of 5 pupils is 11 years. What is their total age? You know, average equals sum of items divided by number of items. The word sum is the same as total. So we get that total when we multiply average by the number. So total or sum equals average times number of items. The average is 11 years and the number, these pupils are 5. So you get 11 years times 5. So the total age is 55 years. That's how we get back the total or the sum of their ages. So the sum of their ages is 55 years. Like I said, average is an assumption of equal share, although it is not true. So you must know it assumes equal share. It says, assuming each of the 5 pupils is 11 years, find the total age. Assuming each of the 5 pupils is 11 years, that's an assumption, meaning it's not true. So it assumes every pupil here of the 5 is 11 years. So what's the total age? Meaning we've got 5 11s. So that's why I've got 5 times 11. That's a better show. That is 5 times 11 and get 55 years. That's how we get back that total. So then we go to the last example today in our P6 class about this statistical data. And now we have gone to probability. Probability within the given information. A basket contains 12 grapes and 6 apples. What's the probability of picking a grape at random? This is just a reminder of what we did in the previous class, P5, about probability. We said probability is the chance of an event happening. So it's found by this formula. Probability is called number of events divided by number of sample space. We said the sample space means the total of whatever is talked about. So they're talking about these 2 kinds of fruits. And now we add the grapes and the apples to get a sample space number. Then the number of events, those things asked in the question. The question is, what's the probability of picking a grape? So all the grapes, the 12 grapes, will have a chance to be selected from. They make the number of events. That's why the number of events is 12. If they are asked, or they are asked for the other type of fruit, which is an apple, you would use 6. Probability of picking an apple, the number of events was P.6. But now they're asking for probability of picking a grape at random. Random selection means picking without seeing in the container. So that's the basket. So just putting a hand in and selecting out without having a choice by looking into the basket. That's called random selection. So say probability is called number of events divided by number of sample space. And now they're asking for a grape. All the grapes are 12. Say number of events is called 12. Then number of sample space means the total number of fruits. So say 12 plus 6. So number of sample space is called 18. Thereby having probability as 12 out of 18. Remembering that much as 12 and 18 are reducible, never should you reduce probability. Leave it as 12 out of 18, and that's the perfect probability. So ensure you answer all the activities now from page 64 all the way to 71 of our term 2 workbook. That's P6 of our school TUC, called Train Up a Child Schools. There are many schools, there are many branches, and all of you, or all our children, do share the same work because they are under the same umbrella, Train Up a Child. So that is about what we have discussed today, and that marks the end of the lesson. For more information about the same or mathematics in general, call this teacher Katimbo on 0776 251655. Alternatively, use 075 72 33066. Otherwise, stay safe.